this TP to be a certain height, and for whatever reason, it's going to be 4x minus 2 is the height whenever the base is x. And in the same aspect, then 4x plus 2 would be the hypotenuse. Okay? And I guess the only reason why I'm doing it like this is because that's what's kind of like on the test, right? So, what we got to do is we have to know one thing, okay? We have to know that a squared plus b squared equals c squared, okay? So, Pythagorean's theorem is crucial. Pythagorean's theorem talks about right triangles, whereas you have a right triangle with a hypotenuse, and the hypotenuse is actually C, and the legs of the right triangle are A and B. Okay, so the legs are always perpendicular to each other. That's crucial in this problem. So right here it tells me that these two are perpendicular to each other. Okay, and so what I want to do is set this up into this equation. So then I know that x squared plus 4x minus 2 squared needs to equal 4x plus 2 squared. Okay? And then I'll know exactly how high I can make this. This would be the exact, and there might be two solutions, and there might be one solution. There might be no real solution in this, because I just made this up. So we're about to find out. Okay. So my first step here is to square everything up. So remember our trick when we're doing squares. Now, the first side, I'm going to show you the method that you always do. So it's plus 4x minus 2 times 4x minus 2. Okay? Equals, and I'm going to show you a trick on the second step. Okay? So in the second step, I'm going to show you the trick. So I'm just going to write this. Okay? Now here's the way we usually do it, and it's called distribution, right? Everybody on the block gets the paper or the clam method. One, two, three, I don't care what you look at it, but we're distributing this to this, right? So we got x squared right here, plus, and then 4 times 4 is 16x squared, minus 8x, minus 8x plus 4. And that equals, and here's the thing. See how we kind of added these up? And now we're going to get x squared. Well, we'll actually get 17x squared minus 16x plus 4 equals, and then there's a trick to doing actually these perfect squares, and what it is it's this squared, 16x squared, and it's this squared, 4 plus 4. And it's this times this times this. It's a trick. It's not something, it works with, it doesn't work with cubes. It only works with squares. Okay? But what it does is it says, okay, 2 times 2 is 4, right? Times 2 is 16. Or times 4, sorry, is 16. So should have 16x, and it's positive. They're all positive. So in this case, it's plus 16x, right? And the same thing happened here, right? Except this time it's negative. So it's minus. So it's 2 times 2 times 4 is 16. But it's minus, so this time it's minus 16x. So see how we did that? So it's a little trick. Something you might want to throw in your toolbox to make things a little faster. Am I recording? Yes. Okay. So, so there's that. Okay? But now we need to solve. So we need to get everything over to one side. So I minus the smaller x from the bigger x squared. So that's why I want to always keep x squares positive, right? So I'm going to minus 16x squared. So that way I have to pull everything from that side. Minus 16x minus 4. And what I get over here is minus 16x squared minus 16x minus 4. And what I get is equals 0, right? Nothing on that side. And this cancels. This doesn't cancel. It actually doubles. So it's minus 32x. This actually goes down to x squared, right? So now I want to pull out my x's. So I'm going to bring that up here. So I have x squared minus 32x equals 0. And so what I want to do, and all I did here is I drug this up so I could do it. Okay, now I just want to factor out my x's. X times x minus 32 equals 0. Alright? So I have two solutions. 0 times a number or 0 times a number. So if this was a number and this was 0, it still equals 0, right? If this was a number and this was 0, it would still equal 0, right? So now I got to set each one of those equal to 0. X equals 0 and x minus 32 equals 0. And then what that tells me is x equals 32, right? Or 0. Now, if I'm doing this, I obviously don't want my space in the TP to be 0, right? I don't want this, nothing. So obviously that tells me in real life this is no solution. That's not going to help me. And if this came up negative, probably wouldn't help me either, right? But this actually came out positive, so it's able to tell me how much space I have. So right now it tells me that the radius of the circle is going to be 32. So how much actual space is going to be inside this? And it's going to be a 64-foot wide teepee. Well, how tall is it going to be? Okay. So what I have to do is if it's 32 here, if x equals 32, then what does this equal? And it's 4 times 32 minus 2. In order to stay at those specific requirements, this thing's going to have to be, oops, why did I do that? That's not right. So, there. So, 4 times 32 would be 128. Alright, yeah, 128. Minus 2, so it would be 126. Okay? Feet tall. 126 feet tall. You know, it's just quite tall, right? And, but that's saying that being this specifically, you know, we want this to be exactly this for whatever reasons, and actually the Egyptians had certain specific things about their their pyramids. They had to be a certain height with respect to the width. Okay, so this isn't out of the ordinary, but remember, I made up this little 4x minus 2 and 4x plus 2. So it's not, it might not be legitimate to having a 126 foot tall pole. That's pretty long, you know. But in this case, that's what we're talking about. But the thing is, there's no pole in the middle, right? No, right? So what's really important, if we want it to be this tall, if it has to be that tall, then I have to, and it has to be this wide, right? Then that means this has to be a certain height too. And that's the whole purpose of this, is saying, okay, if we know we have to have it a certain width, and if we know we have to have it a certain height, then we can find out how long these poles have to be really easily by using this Pythagorean theorem. Okay? And it's, in this case, we already found out what x is. So now it's just a matter of doing the math, and it's 4 times 32 plus 2. And that's what makes it so high. Okay? And so now we're just talking about a hypotenuse, or a pole, that's 2 more than 28. So 128 plus 2 is 130. So now we're talking about a pole that is 4 feet longer than the width. Okay? Or than the height, sorry. So a really crucial thing to know, if you have a constraint on your height and your width. If you know you only have 15 feet that you can have it as, right? And you know you need 12 feet of space in there, right? So this is 6. How long is the pole, right, going to be? Or let's say you're going to add to this, but you don't know how much yet. So guess what you can do there? Voila. You see what I mean? Now, all of a sudden, we're adding x to both of these. Well, that's going to change some things. You know, if we're adding the same amount, because we're adding the same amount to both the height and the width. So actually, we're adding double the amount to the total width. If you think about it, right? Because that's your total width.
Then you make your bottom too small, and your TP hangs down.
That's it.
You make your bottom too big, and your TP's set up off the ground, and you can see people's feet.
See, and this is exactly what I was asking for before. So, are there constraints? And there are definitely constraints. It seemed to me only logical that there are definite constraints. And so these constraints can be looked at mathematically. And we can make the perfect TP for the perfect situation, depending on what you have, you know, that you need. You know, whether you're using it, whatever you're using it for, because obviously it's used for many different things, not just to sleep in. Obviously, you know, for me, I've only used TPs for going in for a sweat, but. I'm sure they're used for multiple purposes. Smoking fish, maybe. I think would be an awesome way. Obviously, would contain the smoke better, to me.
Over in Yakima, they have them like a motel.
Oh, yeah?
People, their TPs are set up all the time.
Okay.